Okay, so one of the main things when it comes to connecting PicoScope to the off-highway machinery is access and accessibility. We all know that it can be tricky on vehicles, but it's even harder on something like a tractor in this case, or an excavator. Mini diggers are by far the worst things in the world to try and connect to, just because everything is crammed in where it is. This is why some of the breakout leads we've included in all of the kits actually are there to help make that accessibility easier. Of course, where needed, we're still going to have to backpin, which is what we've done. So I've set up a small test. We're going to be looking at the cam and crank signal from this engine, and we're also going to then introduce a sync or a cylinder ID from the injector loom. So let's get started. We're going to connect up, and first thing we're going to do is obviously start PicoScope. So PicoScope 7 Automotive is where we're going to need to be, and this is where all our tests will live. With the scope connected, it should fire up and make all the necessary clicking noises. And we have our guided test menu. Now we're going to just cancel that out for a second, and we're just going to go freestyle. So my default settings for off-highway applications, they start with plus or minus 50 volts. Now the reason being is that you're never quite sure whether it's going to be a 12 or a 24 volt system. The scope can handle 200 volts, we know, so actually majority of the systems, actually to be fair, in my experience, everything that I've worked on doesn't get anywhere near to that 200 volt mark. So we should be good, no attenuation needed. Camshaft and the crankshaft on this machine are both inductive. Now we could just go ahead and just use the guided tests, of course, that's not a problem. However, I'm just going to stick with a slightly longer time base as my default settings, so I've chosen 500 milliseconds per division. That puts us into this streaming mode, so we should be able to see the signals as they change on the screen. So we're going to set up and get connected to the crankshaft to start with on channel A. One of the reasons for choosing crankshaft on channel A is the built-in maths channels, and they become really, really useful when you're looking at cylinder contribution from each piston or each combustion event. In this case, I've had to backpin, which is fine because we managed to get the cover off the back of the connector, and we've been very careful, obviously, to make sure that we're not going to damage the waterproof seal that's there. As you can see on the actual scope's trace itself, it has auto-ranged. Now obviously I don't want that, I want to stick to our plus or minus 50 volts. So just go into the channel options and select the manually plus or minus 50. Same thing again then on channel B. So this is where our camshaft is going to be connected. So BNC plus probes, literally plug and play. The software will know what we have connected. And again, I've had to backpin in this situation. Okay, let's just check our settings. And again, channel B has auto ranged, so we're just going to change that to plus or minus 50. And that should give us something on the screen, which is ideally what we want. In any situation, just making sure if you can capture something on the screen, pretty much that's where we need to be to start evaluating. And we can always back the time off, introduce triggers, etc. if we need to make that signal a bit more clear on the screen. Right, let's get the engine started. Okay, captured. Let's just have a bit closer look at the actual signal itself. So as we can see, we can use the zoom tools on the scope software, and there we have it. We can see our cam and crank signals there quite nicely. One thing that we do know about with a lot of off-highway and heavy-duty machinery is that if there is an inductive sensor used for the camshaft, typically, and again, I'd always stress, make sure you look at the technical information before making any assumptions. There's usually a double pulse within the camshaft signal. Cylinder 1 typically fires after that double pulse. So therefore, in some ways, we wouldn't necessarily need to add a sync at this point. However, we will do in just 1 second. So as we zoom in, again, we can see this is our double pulse. So this will be our full 720 degrees of rotation. We have 2 rotations of the crankshaft, and all being well, that looks absolutely fine. Okay, let's go ahead and we're going to introduce the current clamp on channel C to give us that cylinder sync. Now, a word of warning here is where I'm connected on this machine, actually I'm on the back end of the actual engine harness itself. So there's 2 plugs on this particular variety of machine. So I'm only seeing 2 injectors which are on the end. So there's a 4-cylinder engine, so I'm only looking at cylinders 3 and 4. But if we know the firing order, then we should actually be able to make it to determine exactly what's going on. So, current clamp connected. We have a breakout lead inside the cylinder head. It is one of the off-highway breakout leads that come with the Elite kit actually, but you can obviously get those separately from our website. So PicoScope has automatically detected a current clamp. So we now have channel C. Now, I know it's certainly not going to be 1 amp, so pick a range that we know we should be comfortable with. So I'm going to go for plus or minus 20. Probably a little bit lower than that, but again, it's all about getting something on the screen. You could leave it at auto and the software will automatically adjust the range to get it so that you have got something there. So again, let's start the engine up. And typically, as you can see, I've now got a inverted signal, 50-50 chance with current clamps. Now I could go in and actually flip the current clamp round, but I'm not going to. I'm just going to use the software, channel C, channel options, and now we have the invert option. We click the invert, and happy days, we're up the right way. Now how interesting that I said plus or minus 20 amps might still be a bit too high. It isn't. We need to go even higher. So this is where we need to go to plus or minus 50 amps. Right, let's pause that on the screen and we'll switch it off. Okay. Let's have a little zoom in around. And we'll just capture around 2 rotations of the engine, 1 rotation of the camshaft, sorry. Oh. Let's just go back a view, there we go. Oh. Let's get my zoom controls right. There we go then. So, as I said before, the double pulse usually indicates cylinder 1. So if that is the case, we would have cylinder 1, 3, 4, and then 2, and then back to cylinder 1 again. This would mean that our injector that we're currently connected to would be 1, 3, cylinder 4. How else can this capture help us then, sort of with diagnosing potentially intermittent problems with maybe poor performance, customers complaining that the machine's not working as good as what it did before, maybe no trouble codes connected with it? Well, actually having the crankshaft signal allows us to do some clever stuff with the maths channels. Now, there's no need to get too worried or too bogged down with panicking about creating them. There are already some pre-configured within the software. We click maths channels, and then here we have crank A of 36 and crank A of 60. The 36 and 60 represent how many teeth there are on the flywheel. Or sorry, on the crankshaft pickup. Now, without sort of counting them individually, I'm going to just go with crank A of 60. And there we have an actual capture there. So we've actually got the maths channel that's recreated that signal for us and is plotting the frequency change based on the combustion event from each cylinder. So every time the piston comes up, combustion takes place, piston gets forced down. There's a momentary increase in speed within the crankshaft. As the next cylinder comes up on its compression stroke, the crankshaft slows down ever so slightly. So we get this constant sort of ripple effect that takes place. If we have a cylinder that is maybe has poor compression or poor combustion, then actually the cylinder isn't going to increase as much speed, which then obviously relates back to the crankshaft. So in total, you get a slight slowdown in the crankshaft before then the next cylinders build the speed back up again. That repeating event can help you sort of start honing in as to what the problem is. In this particular case, we know that this machine's good, so we don't have any issues there at all. Looking at partitioning this off, we can use the phase rulers to then help identify where each cylinder is. Click the phase rulers. Now a quick little tip here, if you are zoomed in around the capture, where we have the two double arrows at the end of the screen, if you click on those, it will bring that double arrow onto the view that you're in, so in the zoom window. So if you click it again, now you can see we have our 720 degrees that's just come in. If I offer that up to where the injectors are taking place, now we can start to see the effect from each cylinder. So if this was cylinder 4, this would then fire, so that it would increase the speed. Cylinder 2 would then come into here, so this is on its compression stroke before it then fires, so it increases the speed, and so on and so on. So hopefully that helps take a little bit of a look at how we can use some very simple signals, which in all fairness should be relatively easy to get to help start identifying problems that are going on within the engine. All right, I hope that helps.